Hello. In this lecture, we are going to continue with the discussions on limits that we are doing for the syllabus for IIT JEE Advanced and Mains. Okay, and we have done a few questions till now on limits, and we are going to do a few more in order to understand how to execute the questions of limits in general in examination. And sooner we are going to start with continuity also. So just I'm waiting for a few minutes for people to join and then we'll start. So we have done limits till now to a greater extent, and uh, let us do a few more things that needs to be said and done before we move on to continuity. At times there you may feel need of using expansions. So this expansions you'll study in your higher classes, but right now you can use them as a handy tool. Probably I may teach you also of these things in differentiability, but right now let us use these expansions as an easier tool, as a tool for determining some questions relevant to limits which may come in your examination. So these are called as Taylor's expansion, or in particular, if you're expanding at x equal to 0, these expansions are called as Maclaurin's expansions. Okay, and they may come very handy when it comes to a certain type of questions of limits. Okay, so all these things I intend to do in greater detail as I'll do Taylor series expansion uh, in differentiability. Okay, so till then I believe that we use this, and then as I go along, I'll keep doing things. Like for example, I have till now directly written limit x tends to 0 sine x over x is 1, but I'll develop the proof also later on. But right now my focus is somehow to get to questions at first. Okay, so let us develop some of the let us write some of the expansions. So your x, the sine x can be written as x minus x cubed by 3 factorial, x cubed power 5 by 5 factorial, then you can write minus x cubed power 7 upon 7 factorial, so on and so on. Your cosine x, as you can expand about x equal to 0 in this fashion. And this is an infinite series, mind you, this is an infinite series. Okay, you can expand your tangent x as x plus x cubed by 3 and 2 by 15, x cubed power 5, and then you can go along. A few others like e cubed power x, you can write 1 plus x square upon 2 factorial plus x cube upon 3 factorial, so on and so forth. And then you can also write ln of 1 plus x. And what is ln 1 plus x? It is x minus x squared by 2, x cubed by 3. It is from, and then you can, likewise, these are some of the very important ones, okay? Is that clear, Rashid? Should I move ahead?
Yes.
Okay. So while you'll be thinking why I'm using all those things. So at times it is quite handy in few of the questions. So let us do those questions at first and let us understand how to execute them in your questions, right? So let's say for example, I want to evaluate and अच्छा एक चीज दो चीज और कर लेते हैं. Let us do it. Okay. So for example, if I want to find the limit of, I'll use this thing in continuity more of. Okay. That would be fine to use it in continuity. Okay. So I'll do one more thing and then so this is one of those tools which you can use in your exam. Okay. First, let us do a few more things and then I'll move ahead with the other things. So this is Maclaurin's expansion. This is one of the tools which may be handy for your examination. Okay. Another thing that you can think is at times you will find that there are certain forms. Like for example, you may have a form of 1 raised to power infinity. Okay. So 1 raised to power infinity means whatever limit you have, if you are placing your the base is tending towards 1 and the exponent is going towards infinity. If such is the case, then what you can do, you can use the log. and then try to take the limit. You can use the log and then try to take the limit. One of the ways can be to do this way. Is that clear?
Yes, sir.
Okay, so this is one other thing that I wanted to tell you. So let us do a few questions and then we'll get back to this Maclaurin's thing. Okay, so try to solve this question which I'm giving you right now. So let us do a few more questions. So these two things I thought I did not tell you, so that is why I told you. So let us do a few problems on limits and okay, so let us do a few more problems on limits. So let us, you just have to find me this. Limit x tends to 0, e की power a upon x minus e raised to power minus a upon x divided by e raised to power a by x plus e raised to power minus a by x for all a greater than 0. This is what we want to evaluate. So just think about how to go about it. So whenever you have this like x tends to 0, you can clearly see as x tends to 0, your 1 over x would obviously tend towards infinity, isn't it? So what one can see, because see a is greater than 0 already, a is greater than 0, right? A is greater than 0, so this will go towards like e की power minus infinity, this will go towards 0. But one also has to understand that if I'm supposed to find limit x tends to 0, it would be safe to first find left hand limit and then find right hand limit. Why I'm doing it? Because if I find a left hand limit to x equal to 0, this will become e की power minus a by h, and this will become e की power a by h. Are you getting my point? So if I want to find the left hand limit, what it would be e की power minus a by h minus e की power of a by h, and then I have this e की power of minus a by h, and then e की power a by h. Is that clear? And a is given greater than 0. So if h tends to 0, one can understand that 1 over h is tending towards infinity. So if h tends to 0, then 1 upon h is tending towards infinity, isn't it? So if 1 upon h tends to infinity or a upon h tends to infinity, your first term here would become 0. This term would also become 0. Is that clear? And your limit will come out as minus 1. Is that clear?
Yes.
And if you try to find the right hand limit, so right hand limit would simply be, I think 1, because this is e की power a by h and then e की power minus a by h, and this will be e की power a by h, and this will be e की power plus e की power minus a by h. So as h tends to 0, this will tend to infinity. E raised to power minus infinity, this will become 0, this will become 0, and this ratio will, you will get 1 here. So limit left hand is not equal to limit right hand, so you'll write limit does not exist. So your for exam in exam, if your exam has some options which says that limit does not exist, then you can clearly think of finding the left hand and right hand limit in those questions. Is that clear?
Yes.
Okay. Now let us put our attention to another questions and let us see. So let's say this is the question. So this is what I wanted to do. Let's say I want to find limit x tends to 0, and this is 1 plus x raised to power 1 upon x, and then you have this e x minus 1 divided by x. Okay, how to do this problem? So I told you that if I just see this particular, the first term here, I'm referring to this term. So if I want to find limit x tends to 0, 1 plus x raised to power 1 by x, what I can do, see, as x tends to 0, this will tend towards 1. This will tend towards 1 by x. It will tend towards infinity, isn't it?
Yes, sir.
Okay. Another thing that you can see that it's given like you're also given this ex minus 1, right? So you're also given ex minus 1. It is just not that you're getting so what I will suggest is for this question, because see, if you had this limit x tends to 0 and this entire thing was given to you, like this, only this thing was given to you. Okay, then you could have certainly written it as, you can certainly have written it as e, right? But now you have this divided by x also here. Okay, so what I will suggest is try to solve it in a way, like let's say what I've told you, that whenever you have this e 1 raised to power infinity form, what you can use logarithm. This is what I will suggest. You can use logarithm. Okay. So what I'll do, I'll write it as let's say y. Okay. And if I take log on both ends, I'll get this, and I will write log of 1 plus x is equal to log, and limit x tends to 0. And one of the series I have just written, that is ln 1 plus x, you can write it as x minus x squared by 2 plus x cubed by 3 minus x raised to power 4, so on and so forth. And this is only when mod of x is less than 1. So obviously mod of x less than 1 means x lies between -1 and +1. So x tends to 0. It implies that this is tending to 0. That is, it is getting in this limit only, right? That is, x is lying between -1 and 1 only. No? If I'm saying that my x is tending to 0, what does it imply? It implies that I'm talking of this region.
Yes.
Right? Because x tends to 0 means I'm in this -1 to 1 only. So what I can do, I can expand this thing, right? So what I'll do, I'll expand this thing. So what would be the expansion? Expansion would be x minus x squared by 2. And I'll not keep it to very higher terms because x is already tending to 0. I'll keep it to a few terms only. And this is log of. Is that clear? And
Yes.
if eventually I need what is my y. So I'll write that my y is equals to what? So here I'll write my y is equivalent to writing e raised to power 1 minus of x upon 2, right? And plus I should write x square upon 3, and there would be higher terms. I'm not bothered about it anyway. So this is how it will be. Is it fine?
Yes, sir.
Okay. So instead of 1 plus x raised to power 1 by x and all those things, what I'll do, I'll simply replace this thing here. So what I'll do, I'll write limit x tends to 0. Here I'll write e to the power minus x by 2 plus x square by 3, and then plus e x minus e and divided by x. Okay.
Yes, sir.
Okay. And probably what I can do is, one more thing I can do is, I can take e common out from here. So I'll take e common out from everywhere. So limit x tends to 0. This is e raised to power minus x by 2 plus x squared by 3 plus ex minus e divided by x. Okay. And e raised to power x, you already know it is 1 plus x square upon 2 factorial, so on and so forth. So what I'll do, e is already outside, so I'll write e outside, and this is limit x tends to 0. And what you can write here? You can write 1 minus of x by 2 plus, sorry, if I have taken e common out now, so e will not come here also. Okay, x cube, x square by 3, and then there would be some higher order terms. I'm not interested because anyway, if I take x here, higher order terms, there would be something left here, right? So if I have some x cube by, let's say, something, or all those higher terms are also there, because this x will cancel it, so there would be term in the numerator. And because x tends to 0, these all higher terms would become 0 anyway. Is that clear?
Yes.
Don't forget that this e is there, okay? Don't forget this. So 1 gets cancelled with 1. Minus x by 2 plus x. So it will become e, and I'll write limit x tends to 0. X minus x by 2 is simply x by 2. And then this is x squared by 3. And so on and so forth. And divided by x. And I know that if I cancel this up, this will be 1 by 2. There would be some x left here. So as x tends to 0, all this term would go towards 0. So overall, you have this 1 by 2 plus something which is going towards 0. So this will be, I think limit would be e into 1 by 2, which is equals to e by 2. Is that clear?
Yes, sir.
So this is how this thing can come very fruitful for you, like expanding in terms of series.
Yes.
Okay, let us do another question. If I correctly remember, that answer comes out to 11 by 24. Just give me a minute. Meanwhile, I'll give you another question. Do you have anything to say?
No, sir, not right now.
Okay. Just give me a minute. I'll get back to you. So I think there was a question. I don't know. sometimes back I did it. So look, I'll give you any time. Okay. So okay. So try to do this question. Try to do this question. Limit x tends to 0, and this is a ki power x plus b ki power x plus c ki power x divided by 3, and this whole raised to power 2 by x. And don't confuse yourself. This is not greatest integer function. Okay, so this is simply a bracket I've drawn here, where a, b, c's are all positive. Here a, b, c's are all positive. So again, if you look quite closely to this particular question, you can clearly see that as x tends to 0, this is tending towards 1, this is tending towards 1, this is tending towards 1. All of these is tending towards 1. So 3 by 3 is 1, and this is tending towards infinity. So one of the ways you can tackle it is by writing x, y as this entire thing. And what you can do, you can take simply log both sides. So log of y would be limit Is that clear?
Yes, sir.
Okay. Now I want to introduce you something called as L-Hospital rule. However, again, this particular thing we are going to derive once we are. So my idea is to derive all these things lately, but right now I want your progress somehow. Somehow I want that you should learn these techniques, or you can learn these things up first as a way of working. And once you are acquainted with all these things, we'll develop these rules as I go ahead. Okay. So what does L-Hospital rule? How do you do this L-Hospital rule is whenever you find that you have a 0 by 0 form, or if you have an infinity by infinity form. Okay. So I'm writing it here. If you find that there is a 0 by 0 form, and if you have an infinity by infinity form, and your function is differentiable, that is on the numerator and your denominator, your function is infinitely differentiable, then what you can do is you can differentiate your numerator, you can differentiate your denominator separately. Okay, you can differentiate your numerator, you can differentiate your denominator separately till the time till the iteration you can do it iteratively till you do not get a form which you get from where you can get rid of 0 by 0. What I want to say is if you have this form, let's say f of x, and you have this g of x, and if I'm saying I want to find limit x tends to, let's say, L, and if my f of L is like some infinity and g of L is also some infinity kind of thing, so what you can do, you can differentiate it and then again try to evaluate the limit as x tends to. And if you try to evaluate this limit, and if you find that, okay, this limit you are not getting as infinity by infinity form, then whatever limit you are getting, that is fine. But again, if you're getting infinity by infinity form, you have to separately differentiate your numerator and you have to separately differentiate denominator till the time you get a non-0 by 0 limit or non-infinity by infinity limit. Is that clear?
Yes, sir.
Okay, so this is one of the rules you can right now keep in mind. As I go along, and probably if time allows, we'll see the derivation part of this also. Okay, so like right now, I want you to just use it as a tool right now. Okay, so where is my sticker? Okay, here it is. So you have this log y. I can write it as limit x tends to 0. And now if I want to differentiate, because you see, if I take x tends to 0, this will become 1 plus 1 plus 1. This is log 3. Log 3 minus log 3 is 0. And again, x tends to 0. So this is 0 by 0, isn't it? So if I differentiate it, and remember, it is not u by v derivative. It is differentiating numerator separately and denominator separately. So if you differentiate this, you'll get 1 upon a ki power x plus b ki power x plus c ki power x. And then you will get a ki power x ln a plus b ki power x ln b plus c ki power x ln c, and this log 3 would become 0, so you don't have to see about it. And this x will become 1, obviously, so don't have to buy. Okay, so overall, log of y This is limit x tends to 0. And you see, this is 2 upon a की power x, b की power x, c की power x, and then you have this a की power x ln a plus b की power x ln b plus c की power x ln c. Now, if you take x tends to 0, what you will get? You will simply get ln a plus ln b plus ln c. So this is ln a b c, and then you have this 2 divided by 3 here. Is that clear?
Yes, sir.
Okay. So this is 2 divided by 3. So your ln y, I can write it as 2 by 3 ln of a b c. And y, I can write a b c raised to power 2 by 3. Is that clear?
Yes, sir.
If you just take the help of the quotient like rule of logarithms, so this log of y would be ln of a b c raised to power 2 by 3. So y, which is the limit x tends to 0, your required limit, it is equals to a b c raised to power 2 by 3. Is that clear?
Yes, sir.
Okay. So all these things I think we have done. A few more things if you want to do. Just try to find me this limit. So limit, now you're comfortable, or do you have any doubt?
Not now, sir.
So you try to do your worksheet, right? So once you're done with that
Yes.
worksheet now, so at least we'll be able to understand कि कुछ गड़बड़ हो रही कि नहीं.
हाँ, sir.
This is greatest integer, by the way. Okay, this is greatest integer. Now try to find the limit x tends to 0 f of x. Okay, so I'll do it for you, don't worry. So if
It
you
doesn't exist.
you want to do,
Sir, it doesn't exist, right?
okay, it doesn't exist. Good. How do you get the answer? Well,
So, so you calculate the left-hand limit, it will
Okay.
come as 1, and the right-hand limit minus 1. Left hand will be minus 1, and right hand will be 1.
Okay, no, that would not
And
be 1.
it's given that fx is 0.
Okay. So just let me help you out here. You just see the definition part of it. So you see the definition has been given in greatest integer itself. Obviously, your answer is right, but there's a certain thing that you have interpreted. So that's what I'm trying to rectify. So greatest integer x equals to 0. What does it mean? It means your x should lie between 0 and 1, isn't it?
Yes, sir.
So when you say that your right hand limit would be 1, that is wrong, because your right hand limit would be 0, because your function itself is 0 on the right hand of 0. Are you
Yes,
getting
yes,
it?
yes.
By the definition
Yes.
itself, you see your greatest integer x equal to 0 means your x lies between 0 and 1, including 0. And if that is the case, your function itself is 0 here. And if your function is 0, the limit x tends to 0 plus would be 0. And you are quite right about limit x tends to 0 minus. Why you are right there? Because greatest integer x equal to 0 means what? X lies between 0 and 1. And it
Yes.
does not equal to 0 means, here I can write, here I'm writing, it refers to all those x barring this. Okay, so it refers to all those real numbers barring this. So it will obviously include to the left of 0. So to the left of 0, you have this kind of definition. So I'll write limit sine 0 minus h here. So I'll write h tends to 0. Is that clear? Divided by minus h greatest to 0. And what it would be like? It would be like minus of sine 1 divided by minus 1, which is eventually, after all, sine 1 only. So your left hand limit in any case is not equal to right hand limit. Are
Yes,
you
sir.
getting the point? Because minus h greatest integer would be minus 1. So therefore, minus sine 1 divided by minus 1, this will be, so clearly limit does not exist here. Is that clear?
Yes.
A similar question in this pattern only, let us do our greatest integer only. Try to find this limit. You'll not be able to do it right. So let us do another question. Let us try to do another question. I think now you're in a position to do quite many questions. So now we can do a few more and then we'll move to the continuity. Okay, so just give me a minute. Okay, try to do this question then. If you can do this, then I want you to find limit x tends to 1 modulus of x cube minus x divided by x minus of x cube. You just try to find this.
So the left hand limit will come out to be 1 and right hand will be -1. Yeah.
So let me do the question. Okay. Okay. So what do you say? The left hand limit is. Just let me find an answer to this. So first is limit does not exist. Okay. So answer is limit does not exist. Let us see. So x tends to 1 means what? So you can do this in this fashion. You can write modulus of. Acha, ek kaam karo, no? Let us first define this modulus, right? Let us first. So you always remember modulus is equals to what? It is equals to x. If x is greater than 0, you can take equality anywhere. मतलब यहाँ भी लेना चाहो तो इक्वालिटी ले सकते हो, यहाँ भी लेना चाहो तो ले सकते हो. After all, -0 is equal to plus of 0, so anyway it is fine. Okay. Now, what I can do is see x cube minus x would be greater than 0 or greater than equal to 0 only if x into x square minus 1 is greater than 0, isn't it? And here you can take two cases. One case you can take that, let's say if x is greater than equal to 0, if x is greater than equal to 0, then your x square minus 1 should be greater than equal to 0. Only then their product would be greater than equal to 0. Is that clear? So one solution would be consisting.
Yes.
One solution would be consisting of. I'm trying to expand this particular modulus of x cube minus x. Let us see if that helps us during the question. Okay. So like what I'm trying to do is I'm trying to find at what all points of x, at what all values of x does x cube minus x, this particular expression is positive. Okay. So if that is the case, you can see that your x should lie between -infinity to -1 union 1 to infinity. And
Yes,
x
sir.
is greater than equal to 0. So intersection would give you only this solution. So one of the points where one of the values, one such values or set of values can be 1 to infinity. So if your x lies between 1 to infinity, then this would be positive. Another way to look at it is, let's say if x is less than not equal to 0, if you say if x is less than 0, then your x square minus 1 should also be less than 0. What does it mean? It means then x should lie between -1 and 1. And in that -1 and 1 also, you are only supposed to see x less than 0. So your x should lie between -1 to 0. Okay, is that clear? So what I'll do, I'll write it here. So this x cube minus x modulus I can write it simply x cube minus x, because if it is positive, then as it is, you can return. Because see, if mod of x is, whatever argument is written inside, if it is positive, then return it as it is. Like modulus of x, you can simply write it as x only. And modulus of x cube minus x, then you can write simply it as x cube minus x here. Okay. And this is true for all x belongs to minus 1 comma 0 union 1 comma infinity. And for all other points, your x cube by this will be negative. So you can simply place a negative sign in front. So instead, this will be x minus of x cube. From where to where? For all x lying between minus infinity comma minus 1. Is that clear?
Yes.
And you can take my is here itself union uh, 0 comma 1, because for 0 comma 1 again it would be uh, for 0 comma 1 it could be again negative only, because are you getting my point? That you can check on your own self. Matlab, for barring these values, it will be negative. So if an argument inside of modulus is negative, what do you write? You write a negative of it in order to make it positive. So if argument which lies inside the modulus is negative, you place a negative in front of that. So overall it becomes positive, because absolute value means a positive value of that particular number, the magnitude of that number. Is that clear? Now, if you
Yes.
if you evaluate this left hand limit, what it will be? So let us first evaluate left hand limit. So 1 minus f of x, and f of x is this. So what does it imply? It implies limit h tends to 0, and this is f of 1 minus h. And whenever I'm referring 1 minus h, I'm referring to a definition which is to the left of 1. To the left of 1, you know that modulus of x cube minus x can be written as what? It can be written as x minus x cube. So it can be written as 1 minus h minus 1 minus h for whole cube divided by simply 1 minus h and minus 1 minus h for whole cube. So I think you were right. So this limit would anyway come out as 1 only. Is that fine? Left hand limit was 1, right?
Yes, sir.
And the right hand limit, you can clearly see that if I want to find the limit to the right hand,
-1.
this will be, I think, x cube minus x uh, divided by x minus of x cube. So this will get cancelled, will become -1. So clearly your left hand limit is not equal to right hand limit, and therefore your limit does not exist here as well.
Yes, sir.
Okay, is that fine?
Yes, sir.
Now try to do this question, and I think if I'm not wrong, this question was asked in one of the examination, and I'll give you this question, but till then you do this question. Till then you do this question. I think this would be good for you to attempt this one first. Will you be able to do this? I don't know. Chalo dekhte hain. So you do this one meanwhile. So try to do this question. Limit x tends to 3 minus, matlab to the left hand limit, to the 3 x minus greatest integer x divided by x minus of 3. So did you get an answer to that? So if you want to find 3 minus h, it implies what? It implies limit h tends to 0. And
Yes,
here
sir.
I will write 3 minus h, and 3 minus h greatest integer is simply 2 divided by
Yes, sir.
3 minus h minus 3. Is that clear?
Yes.
Okay. So what do you think the limit should be? The limit should be, this is, I think, limit h tends to 0. This is 1 minus of h divided by minus h. So if h tends to 0, this will become 1, this will become minus infinity. Is that clear?
Yes.
So this particular thing will go towards minus infinity. Is that clear?
Yes.
So don't confuse yourself that limit cannot be infinity. It can be infinity. Okay, it can
Yeah,
be.
yes.
Okay. Because what does infinity say? It simply says that your limit is tending towards very large quantity, nothing else. Okay, one other question that I'll do, and then we'll break. I'll do another session. So probably today we'll finish with this limit thing, so that you are. Then we'll see more questions also, but we'll progress further in this.
Yes.
You need to find what is that value of n, such that you get a non-zero finite limit. But in order to get a non-zero finite limit, what should be the value of n? So I'll do it very promptly. So I think cos x, you know that as x tends to 0, your Maclaurin's expansion becomes x square minus 1 minus x square upon 2 factorial x to the power 4 by 4 factorial. And your cos x minus 1 in that case would become x square by minus x square by 2 factorial plus x to the power 5 by 4 factorial minus x to the power 6 by 6 factorial. So
Yes.
it will be simply x tends to 0. Here I can write minus x square by 2 plus x to the power 4 upon 24, and then so on and so forth. So I'm not bothered about it. And here I can write what? What is e to the power x? E to the power x is 1 plus x square upon 2 factorial minus, sorry, plus x cube upon 3 factorial, so on and so forth. So if I subtract cos x minus e to the power x, what I'll get? I'll simply get minus x and minus x square and so on and so forth. So I'll simply write minus x square, so on and so forth, divided by x raised to power n. You take x square here common out, you take x here common out. So what you will get, you will simply get limit x tends to 0, and here you will get x raised to power 3. This is minus 1 upon 2 plus x cube upon 24. And here you will get what? Again, if you take x common from here, this is 1 minus x, and then this is divided by x raised to power n. So eventually, as x tends to 0, this would become 0, this would become 0. So overall, this would become half only. If you multiply, this is minus half plus minus 1. This is minus half into minus 1. This will become half. But if n is less than 3, if n is less than 3, so obviously if n is less than 3, then this will become 0. Isn't it? If n is less than 3, then this will cancel this. So there would be something left in terms of x in the numerator. If n is greater than 3, then this limit would become infinity. Are you getting my point? If n is greater than 3, then this will get cancelled, and there would be something left in the denominator. And only if n is equal to 3, your limit will come out as half. So for a non-zero finite limit, your n should be equal to what? 3. Is that clear?
Yes, sir.
Okay. So we'll meet in the next session. Okay.
Yes, sir.